All right, sample problem 4.10 says magnesium is the second most abundant metal in seawater after sodium. The first step in its industrial extraction involves the reaction of magnesium with calcium hydroxide to precipitate magnesium hydroxide. What mass of magnesium hydroxide is formed when 0.180 liters of 0.0155 molar magnesium chloride reacts with excess calcium hydroxide? So this can be a scary problem. I mean, there's a lot going on here. They've got some numbers, some concentrations, some volumes. They've got different species going on here. So I know these problems can look a little bit scary. The first step is always to start writing down what you know and figuring out what they're asking for. And I immediately see that they're giving me some information about magnesium chloride, and they're asking about some information about something totally different. And that is a clue that my conversion factor is obviously going to have to be a balanced equation. The only way to convert from units of one thing to something totally different is to use the balanced equation. So I'm going to start there. Okay, so what are my reactants? They tell me in the problem, it says that magnesium chloride reacts with calcium hydroxide, right? And it says it's going to precipitate magnesium hydroxide. And what's our other reactant going to be, right? Remember, this is a precipitation type reaction. So these things are just trading up partners. The cation of one goes with the anion of the other. So magnesium and hydroxide, that's how I get magnesium hydroxide. The cation, right, the positive thing is calcium, and the negative thing of the other one, chloride. So that's how I'm going to get calcium chloride over here, Cl2. And now I have to include the physical states of these things, right? And let's check it out, right? This is going to be AQ. This is going to be AQ. Those are both soluble. This is going to be a solid. They told me it was a precipitate. This is going to be AQ. Now, how did I know that? I used the solubility rules. Let me show you. I've got them down here. Okay, so chlorides. I have a rule for chlorides. It says all common chlorides are soluble except for chlorides with silver, lead, copper, and mercury. Magnesium is none of those exceptions, so this is soluble. It gets the AQ. Calcium is none of those exceptions, so this is soluble. It gets the AQ. All common hydroxides, right? This is OH. This is calcium hydroxide. All common hydroxides are insoluble. That means they will all be solids except for group 1A metals and calcium, strontium, and barium. Here I have calcium, so this is soluble. This would be AQ. Here, I do not have one of the exceptions. Magnesium is not a group 1A. It is not calcium. It is not strontium. It is not barium. Therefore, this one is going to be insoluble, which means it's going to be a solid. So that's how I could use the solubility rules to determine these physical states. And you need to just memorize those solubility rules. Now, the next step is we need to check to be sure things are balanced. I've got one magnesium, two chlorides, one calcium, two hydroxides, two hydroxides. It is balanced. So now I can start to answer this question. Now, they've told me that I have 0.180 liters of magnesium chloride. Okay? That's the amount of magnesium chloride. They've given me a volume as the amount. And I need to figure out the mass of magnesium hydroxide that forms. So I've got to ask myself, how can I get from magnesium chloride to magnesium hydroxide? And the answer is this balanced equation. This is my conversion factor, right? It will let me go from magnesium chloride to magnesium hydroxide. Now, these stoichiometric coefficients are in moles. I have liters, so I've got to figure out how can I turn these liters into moles so that I can go from this one thing to something totally different. And the answer is in the problem. This says that it's 0.0155 molar magnesium chloride. That means moles per liters. Remember, the units of molar equals moles divided by liters, which means I can use this as a conversion factor. I can go from liters to moles or moles to liters. So since I have liters in the top, I'm going to put liters in the bottom. So in 1 liter of my magnesium chloride, I have... No, sorry, I told you wrong. No, that's right. In 1 liter, I have 0.0155 moles of magnesium chloride. Let's do our unit math. Liters divided by liters are going to equal 1. So what's this going to equal? I'm going to have 0.18 times 0.0155 equals, I have 0.00279 moles of magnesium chloride. And now I can use my balanced equation for my conversion factor, right? So let's see, what can I do here? I've got, let me get that erased first. There we go. From my balanced equation, for every 1 mole of magnesium chloride, I can make 1 mole of magnesium hydroxide. And let's see, I've got moles of magnesium chloride divided by moles of magnesium chloride. They cancel each other out, right? Let me move this up here so I can have a little more. And that's going to equal 0.00279 moles of magnesium hydroxide. But they want to know a mass, right? What is the mass of magnesium hydroxide? So I can now use a conversion factor that will get me from moles to mass. Moles of magnesium hydroxide. And that is the molar mass. Remember, the units for molar mass from the periodic table are grams per mole. So if I look at the periodic table, I'm going to add up. Let's see, I have 1 magnesium plus, let's see, I have 2 oxygens, so that's 2 times 16, plus I have 2 hydrogens, so that's plus 2 times 1.008. That tells me that that my molar mass is then going to be, let's see, 58. So in 1 mole, let me do this, 1 mole of MgOH2, I've got 58.33 grams of OH2. All right, let's check our units. We got moles divided by moles. I'm going to be left in grams. So that is then going to equal, so I've got 0.00279 times 58.33. I've got, and that equals 0.163 grams of magnesium hydroxide.